Okay, I've started. Yeah, so as I said, we'll start with how to use the pace cluster, and then we'll just have a tutorial on C and the debugger, how to use the debugger. So we'll start with how to use pace cluster. So using the pace cluster requires GeorgiaTex connection to GeorgiaTex VPN. This is the first thing that you all should be doing. And So you have two ways to connect to the GeorgiaTex VPN. One is from browser and one is from by downloading the application, the software client. So I prefer you should download the software client and then proceed with it, because when you log in through the online VPN, so you can just access this website in the browser. So there are two ways to access the cluster. You can have web-based user interface which can be accessed in the browser and also from your own terminal. So I'll give you an idea how to do using the web-based user interface. So here, when you access this website, connect to VPN, you access this website, you'll have a space screen, and wherein you'll have to log in through your GTSSO and then uh, access whatever, like we'll see. I'll like go hands-on as well. I'll just take you through from these slides first. So there's something called login node, to which you can go through this IC shell access. The button over there, you can see this login node. So when you access the cluster, there are separate login nodes and there are separate compute nodes. So login node, you can use your login node to compile your program, but not run the program. So when you run your codes and run the program, so it usually consumes like very high CPUs and then CPU memory, and then maybe others who have logged in onto that node, the login node may feel some uh, like lag into the system. So if you still do it, you'll be kicked out of the login node. So I prefer that you use compute nodes to run your jobs and not the login node. So when you first you access the login node, you do everything like whatever you want to do, coding and all everything, because requesting compute nodes takes like it is at a cost. I mean, when you request compute nodes, it'll start like whenever the node is allotted to you, they'll start billing you for that. So everything, the development and all, can be done on the login node. So that you can use IC shell access button from clusters option in the navigation bar over there. And when you actually want to run the code, the program that you have compiled, you you can do it using the interactive shell. So you can just request interactive shell of that compute node. So as we have the terminal for the login node, similar terminal you'll get on the web browser for that particular compute node, whichever will be allotted to you, or multiple nodes if you request. So yeah, once you go there and then you just uh, request whatever configurations that you need, what memory you need, whatever I mean how many nodes you need, multiple things. So then click on launch and wait. So when you click on launch, according to the availability of the resources, you will be allotted the job. So the nodes. So once you are allotted the nodes, you will receive an email on your GeorgiaTex email ID, and then you can just start whatever you want to do. This is called an interactive session. So why is it called an interactive session? Because you will be notified and then you go and then you work on the terminal doing whatever you want to do on the node. So there's one more way, which is like you don't have to keep monitoring. You just give the script and you just tell that, okay, this is my job, this is my script, and you run the program and just give me the results. That is some other way. So this is called as interactive way, because due to that reason. So next is accessing the cluster using the command line. So once you're connected with this VPN client, Then you can access the cluster also using the command line. Not necessarily you'll have to go through this web browser and all. You just use your terminal. So when you open your terminal, you connect to the VPN, you open your terminal, and then whatever system you're using, you just have to type. You should have SSH client installed in your system. This is the requirement. When you can just type SSH in space your username @ login -ice.pace.gatech.edu. So when you put this, they'll ask you for the password. You just put your SSO password and you'll be in. So everyone registered for the course will have access to this system. So if you are facing any issues, you can always contact us and we'll let you know how it works. So when you do this here, SSH and your username @ this address, you will be logged into the login node. So whenever you do an SSH, you will be in a login. One login node will be assigned to you. There will be multiple login nodes. There are multiple login nodes on the Pace cluster. So one of the login nodes will be assigned for you. So now we'll talk about requesting compute nodes. As now you know that how to log in onto a login node to do the development, to do the, let's say, compile your programs and all. Now actual thing comes when you want to submit or run the job. So there are two things, this is interactive job and batch job. So when you request compute nodes, you can either do your all the thing that you do running and all, because when you run a program, you might have to just go and check whatever the CPU usage you have, or maybe what memory is being used in the runtime. I mean, when the program is running, that time you can use the interactive job. But if you just need the results, you can just use the batch job. So what is interactive job? So you just use this command salloc -n1. N1 is again one node. N tasks per node is 4, means 4 CPUs on that node. This number cannot exceed the number of CPUs available on that node, particular one node. And then this is time. For how much time do you need? This is one hour requested. So you'll just get, so this you can do, this interactive job you can request from your login node. When you SSH into a login node, you can just type salloc and n1, then you'll get whenever the resources are free, you'll get the uh, node that you have requested, or maybe whatever configuration you have requested. But then yes, as it is an interactive job, you'll have to wait till you get the job. If resources are not available, you'll just have to wait for this on the same terminal screen. You cannot close it. Yeah. For the batch job, you will need a bash script which contains the required configuration for the compute nodes. So whatever we are typing here, N1 nodes, number of nodes, number of like whatever number of CPUs you need, memory you need, all those configurations you should be embedding, like putting it into this job script that you will be writing to submit a job. And also alongside that, you'll need the commands that you need to run your program once the nodes are allotted. So I'll show you an example of the job script. Yeah, here. So this is an example which you can use. So I'll just explain how this works. So the top part here, what it does is it will actually request the nodes of these configurations for your usage. And the part after this will be like, you just have a node now and you put whatever commands you have, you want to run your job. So it's like GCC, you're compiling code or something like that. Usually what we do is we have the executable, we just run the executable. So that you can do over here. So let's say I'll give an example. You've requested 2 nodes and maybe um, um, for now here you have requested, let's say 2 nodes and 2 CPUs per node with 6 GB memory each. So you have like 6 and 2, like 12 GBs per node. It's like 2 nodes, so it's 24 GBs in total. So again, you're using this two nodes, let's say, and when you run this, like you just say echo hello sleep 50 and echo bye. So this will be used only by one CPU, like, so you don't need even like two CPUs and two nodes over here. So when you actually run parallel codes and it onto multiple CPUs, you can this actually makes sense when n tasks per node equals to 2 or 4 or 10, whatever you need. So if once you have this job script, you can have .batch or you can have .sh, anything, it's fine. So what you do is you type this command sbatch job script and the script name, whatever this you have written. So yeah, I forgot to explain this thing, like each line over here, because now this is the job name that you will be giving. So here, when you write as batch hyphen hyphen job name, this will be the name for your job, like unique name that you want to give for your job, which will be seen in the scheduler and all those places. If you want to recover the information about your job and all those things, you just it's just the name. Sbatch n to capital N or maybe hyphen hyphen nodes you can write equals to 2 will be number of nodes. Nodes means number of like the um, if you know the how the cluster is like it's like multiple nodes are interconnected to each other. So you're requesting two nodes. I'll talk about the configuration of each node later. Here n tasks per node is how many processes you need, how many CPUs you need on each node. And SPatch mem per GPU, mem per CPU is 6 GB. That's this also you can change. And then SPatch hyphen T or maybe hyphen hyphen time equals to something will be whatever time for how much time you need those resources. According to that, your build again. So for now, you'll be using it like it's free for everyone. So whenever you actually go and request for your own purpose, you actually have to pay a lot. So this is like very useful. So you'll have to manage all these things, how much time you need. You should have an idea about how much time does your job take, everything. So sbatch hyphen hyphen output. This is the whatever you write here, testjob.j.out dot mod j.out is it's like this will be the name of your of the file that will be the output. I mean, whatever you run the code and what you get the output in your terminal, it will be copied into this file by the scheduler itself. Like so by Slurm does this thing. So you give your output file name that you want, everything will be printed into this file. And here this modulus J uh, will be the job number. Like whenever you submit a job, you'll be assigned a unique job ID. So this is the job ID. So every single time you submit a job, test job dot whatever job ID is assigned to you will be here. So you can have those multiple files if you submit it multiple times. Mail type, sbatch mail type here, begin, end, and fail, like whenever. For the beginning of when you want to receive the notifications, like when the job has started, when the job has ended, or maybe if the job fails, you can have these notifications on your email. And mail user, you can give your email ID over here. Further, whatever you have is like you load the modules, like whatever you want, whatever modules you need to run for the purpose of running your code, you need to load those modules, and then whatever the executable file and the arguments, all those things will be below this. That is like according to you. I mean, yeah. So on IC cluster, there are. I'll just give you a overview. I mean, how the cluster is. So it has 60 Intel CPU nodes with 24 processors each. So 24 CPUs each. You have 60 such nodes. So and 4 AMD CPU nodes with 64 processors each, and 98 GPUs in total with 19 GPU nodes with this configuration, NVIDIA Tesla V100s, where which these 19 GPU nodes will have 1 to 4 GPUs per node. This 10 GPU nodes with NVIDIA RTX 6000 and 4 GPUs per node. this I think this yeah, and here 4 GPU nodes with NVIDIA A100s, 2 GPUs per node you'll have, and then 2 GPU nodes with NVIDIA A40, same 2 GPU nodes, and then similar thing here, AMD MI 210. So here there are few Slurm commands that you will need when you once you run your job, or maybe how to handle the job once you submit it. How do you cancel it? How do you see the status? How do you see how long it has been running? So all these things you can always go and see. This you can see on your login node as well. So to check your job status, once you submit a job using the command that we saw here, sbatch and the script, so you can check your job status using sq-u and your username. Then if you think that your job, like once you run a job and it immediately generates the output file, and if you just keep on checking the output file, or if you see that the output that you're receiving is not what you're expecting, you can just cancel the job. So you use scancel and then you use your job ID. Whatever is assigned, whenever you submit a job ID will be assigned to you. If you forget your ID, you just go sq-u and your username, you'll be able to see whatever ID your job is running on. So you can just check this. So once your job is complete, you cannot view your job in sq, it will be out of the queue. So you can see this thing at by putting this command, sacct-j, and then your job ID. You can see how what all processes and all those things, you can see that. Then if you want to review the completed jobs summary, like this is the pace job summary, is some command made by the people or like managing the cluster. So it makes it easy for you to visualize the entire information about your job, which maybe using the slurm commands, it will be very complicated for you. This would make it easy. And also additional commands that you might or might not want to use is sinfo. So sinfo will show whatever like we saw here, like all these nodes, whatever available architecture and whatever available CPU nodes, GPU nodes are there on the cluster, you can see using sinfo on how many are currently running, how many are currently idle, occupied, and all that thing you can see using sinfo. And yeah, srun is used when you will actually dive into the MPI and parallel programming. So srun you can use to run your parallel jobs. So we'll come to this later in the course. And yeah, so I'll just give you hands-on about the same thing.
Can I quickly add a couple things?
Okay, sure.
Yeah. So first, some practical points. If you are using VS Code, another way to run interactive jobs or editing is using the VS Code's remote SSH extension. You can use that to quickly edit and run your code. And also some common mistakes or problems that is encountered is around the submission times for homeworks, the cluster gets very busy and there are, as we saw, very limited resources. Even 10 hours before, you might have trouble allocating any resource, and then you might miss the homework deadline. So you might want to be a little bit early, especially using Pace. And another problem that we encounter a lot is sometimes the students think they're running uh, on the allocated resources, but they actually run on the login nodes, or the interactive jobs they allocated, they run out of time and they end up running in the login nodes and they don't get the numbers they want. So that's another common problem. And yeah, I guess. And another problem is if you have taken other classes that required you to use Pace, and you might have some default settings or profiles because of the previous classes. So your packages might not be properly set. So you might encounter problems like setting up your packages. So you may want to make sure that your packages are aligned with the ones that we specify in the homeworks or in the assignments.
So
yeah, I guess we can go ahead. I think there's a question. Yes, you can check it by just typing the command host name. And for example, if you see Abhishek's screen right now, he's on the login node. He's on the second login node. And as soon as he allocates an interactive job, you will see that after the add, the address of his user will change.
Yes.
Or you can just type hostname and you can see that you're on the login node.
Yes. So I'll just maybe I can just, yeah. So I've just so this is SSH, my username, login IC base. So put your GT password. You're allotted. See, now login IC3 is allotted to me, and this is a login node again. So I'll once I'm on a login node, I can do all the development over here. And when I want to actually run my code, run my program, so I'll just either get salloc, the interactive node, and run, or if it's a small program, or it'll take like 2 minutes, 5 minutes, you can just keep watching it, and then go you on this interactive node, or else you just submit your job script if it's a very long thing, because here you'll have to keep your terminal open for this thing. So -n1 and maybe and just copy that command that we were using here. Yeah, so this is what we saw. So here we've requested one node and 4 CPUs and for 1 hour. So here you can see interactive job name, interactive. You've assigned one, and here the address changes. So this is the address of the compute node. So I'll just show you sinfo, as I said, it will show you all the nodes available. So I'll just here you can see. So COC CPU, and there are 3 nodes, COC CPU 61 nodes, this is state, mixed state, these many are idle, and these are the names of particular like respective nodes. Like here you can see the names of the nodes. COC GPU, base CPU, base GPU, IC CPU. Mostly you'll be assigned, I'm not sure, like mostly IC CPU and IC, or maybe base can also be assigned to you. So this is sinfo that we saw, and then this is the interactive shell. I'll show you. I'll just exit this node. Yeah, now it says that job allocation has been revoked. So the job that was allocated has been revoked. And I was in the I was on the node, and now I'm again on the login node. I was on the compute node. So I also have one. I have a script here. So the same script I'll show you. So whatever we saw, I've just commented out these two. This is according, like if you want, you can just do it. So I'll just try to run this. So here module purge is like, so yeah, like if you don't know about what module is, it's like when you need to, when you work on a cluster, like everybody like your request might be different for some different packages. Some other person's request might be different for some other packages. So what you do is you actually contact the like people who are managing the cluster, and then if your module is not already installed, you just ask them to install, or maybe you can just check if your module is not installed, or is it installed using module avail. So, and then if it is installed, you just write module load and the name of your module. Here Valgrind is a module that we will be needing in our first homework as well. suggest. And module purge, it what it does is whatever previous modules are loaded will be unloaded, because sometimes what happens is by default there will be some modules loaded and your development environment might not need those modules. So you just module purge, and then you load all your modules, and then you give all the commands that you need. So I'll just run this quickly. Sbatch and the job script that I have. So submitted batch job 263186. Now this is my job ID. If I don't remember, it's fine. I'll just write sque hyphen u. Yeah, I can see here. So, but then if this I've requested, because I have like sleep command in my uh, program, so it's like still active. Otherwise, if you have like, if your program is just going off, it'll just go off in like 1 second. You won't be even be able to see in this SQ. By the time you type SQ and this thing, the job might have been off if your program is giving some error or the other. So, but then you always have your output file where you can check whatever the output your code is giving, whatever the program is giving. So I'll just cat this cat. Yeah, so this is the file. So it is still running and we've just received hello. And after that, it's still in that sleep thing. Here you can see job ID, user ID, account, and then the job name that I've given is test job in the file. And the partition that I got is COC CPU that we saw in the S info. So again, just check what all commands. Yeah. Yeah, so I'll show you how to cancel a job. That is also necessary. Yeah, so you just write scancel 263186. Now you check SQ, there's nothing. And if you just type SQ, still you don't see anything. So yeah. What else? I told you cancel. Okay. Paste job summary. I'll show paste job summary and SACCP. Here's this command, paste job summary, and the job ID 263186. So yeah, what it did, everything. So this was the bash script that we ran. So this is like they're making it easy for you. And yes, so this is the entire job summary, how long it ran. So it used CPU time was for 320, as I cancelled after 3 minutes 20 seconds, something like that. Wall time, all these things. Yeah. And then also you can also use SECCT -J and then 263186. Yeah, here you can see. So these are the job IDs, and then there are some batch. These are the different batch IDs which are created internally by the Slurm manager. So this is yours. This is what you did, and these things are by the Slurm. So allocated CPUs, everything you can see here. So yeah, and we have one more thing. Like you can also do this like scontrol show job 263186. Yeah. So you can see this is the slurm command that you can use. But when this helps when like you have requested some configuration of nodes and you're still in the queue. So here you can actually see how long you should be waiting, like what is the estimated wait time and all. You can see here. I think it is not here, somewhere around here it shows actually if you're on the wait list expected time. So you can find it here in this file. Well, that won't be an issue if like the cluster is not crowded, but then it is very busy, then you can just have an idea from here. That's all I think for the today from my side. Yeah, one more thing, I'll just take you all quickly through this. Yeah. So interactive, like you can also go through the browser I said. I'll just show you here. Can you see my screen? So once you log in to this link that we have given, you can just see here clusters. I see shell access. Yeah, you're in. Here you're in on the login node. So they've allotted login node 1 to me. Again, yeah, this is the way we got a login node. And if you need a compute node, you can actually just request like editor VS Code. If you're comfortable, you can also request interactive shell or maybe interactive desktop. You'll just directly get the computer on the other end, where you can also use some GUI features and all over here. So I'll just give you an example of one interactive shell. How do you request? You click here. This is for the compute node, for requesting the compute node. Login node, you can go it from here. You have these many interactive apps that you can request. And here, you can keep this as default. And then whatever you need, you can mention it here. How many nodes you need, you can write it here. So the Intel CPUs have 24 CPUs per node. You can at max you can request 24. You can't go above that. You can't go above that. So you can just, if you want GPUs, you can request GPUs, memory per core, everything. You can just mention all the configuration that you need over here. The time, the font size of the terminal, you can give it here, and then you just launch it. I don't need an email right now, but then if it is very busy, you can also notify yourself. So it's still queued, and then it'll be allotted in a minute. Yeah, you got the node, and when you want to go to the node, you just have to click on connect. Okay, this I actually accessed it using the online VPN, so I'll just close this. Yeah, this is the SSL login and all those things that you'll have to do. Yeah, interactive apps, interactive shell, launch. Delete this, or maybe I can also go to this. It's fine. I can go now here. This is one. So this node is allotted to me, compute node here. And here again, one more I got. This is something else probably. Yeah, this is a different node because once I get a node, it is busy. So if you info right now, you'll see that this node is busy and it can't be allotted. All those things you can explore on your own. And if you have any questions, you can always reach back to us. And if you want to know more about how to go through these commands and all, you can delete a job from here as well. Yeah, that's all from my side.
Yeah, I saw an important question, whether a student asked whether we can use our own GPUs to run the code. So first, some of the assignments we will do, they require multi-node setups. So in this setting, when we use our own resources, we are limited to a single node. And another thing is we all want to be in the same page, meaning that when we use the clusters, we will all use the same modules and the same type of resources. And this way we can get some consistent results, even though they're not exactly the same. And this makes it easier for you and also for TAs as well, because when we are grading and reading your write-ups or results, we want to make sure that everyone is on the same page. So I would advise using the clusters, not our own resources. But for the project or for your own practice, you can use your own resources. Okay. So let me share my screen. Okay, I need to reopen.
Khan, you're not audible. You're on mute.
Oh, I'm sorry. So for the question, yes, we will use C and C++ for the assignments, but for your own projects, you can use other languages if you find it necessary. So we will briefly cover the GDB debugger for C and C++, and we also have a quick coverage on C. We have a quick review on C, but if you are all familiar with that, we can skip that part as well due to time constraints. Yeah, so let's start with GDB. So what is GDB? So it's a debugger for several languages. For this class, we will use it for C and C++ debugging. So it allows us to inspect what the program is doing at a certain point. And it makes it easier for us to find the problems in our codes, like segmentation faults. We have a link here for the documentation for GDB, and we will share the slides later, and you can go and check them out. So first, how do we use GDB? So there's for the compilation, we only need to add the G flag to enable debugging symbols. Let's say that in the original way, this is how we compile our program. And when we want to enable the debugging symbols, we just need to add this G flag. As an example, let's consider the very simple code piece on the right and named as test.c. So if we want to compile it with debugging support, we just add the G flag here. So some basics, once we compile our code, we just need to run our executable with GDB. And using the default modules in PACE, the GDB should come with it. And in this case, we just use the GDB command to run our file. We can also do a more hands-on way. Let's say that we have this test.c, which is the exact code we had. And we just need to run GDB test, and here it should just load the program. At this point, we haven't run the executable yet. To run the executable, we just need to write the command run. Oh, I'm sorry. So GDB has an interactive shell, and this is like any shell we use in like any Linux computer. So we basically have different options. We can use like help command to learn more about the commands we have. Let's say that we have a specific command called backtrace. We can learn more about it using the function name. And we can also use the arrows to go back and forth bit in the history. So basically, once we loaded the file, we just need to run our program. And this is just, we can either just type R or run, and it will run our program. And in the case that that if we don't have any serious problems, our program should just run fine. But if there are some problems, then we should get some important information like what is the line number that the program has a problem with. And so here, if we don't add the debugging symbol when we are compiling, the program, we can still use GDB, but when we have errors and we run our program with GDB, then we won't get accurate information on the line numbers or the function names. So that's why we want to add the debugging symbols when we are compiling our programs. Yeah. So we can also go through some basics. We have the list command, which will display the program we are executing, and then basically one of the most important commands in GDB is putting breakpoints. So when we put a breakpoint to a specific line, it means that once we run our program will stop executing at that point. And at that, once we stop, we can try to display some useful information. For example, let's say that we display our program and then we put a breakpoint to line 5. And let's say we run our program again. And at this point, we can print what's the value of A. And here it says that value of A is 0 at this point. We can also use the info breakpoint command to see the breakpoints we put. In this case, if we type info B, we will see that in the main program test.c, we put a breakpoint at line 5. And we also see that this breakpoint is right now enabled, which means that every time we restart our program, we will have a breakpoint here. But we can also disable or enable these breakpoints by using disable enable command, such as disable B, and then if we run it again, it should just skip the breakpoints. So we already went over the print command. Let's see. Yeah. So there are also other useful commands. Instead of breaking at a specific line, we can put the break to function names as well. In this way, every time we hit a specific function, our program just will break. And the continue command, it allows us to go to the next breakpoint. And the step or the next command, they will just allow you to go to the next line or the next subroutine in the execution. And actually, one of the most important commands is the backtrace. Let's say that our program has a segmentation fault and it crashes. And we can use the backtrace command to see the function stack, function call stack at that point. As an example, let's say that we have another example. We loaded this example. Let's see our program. This is a very simple example, and I'm sure most of you can identify the error here. We have an int pointer, but the pointer is not allocated, and we are trying to initialize an unallocated pointer. So when we run this program, we will basically get a segmentation fault. And using the backtrace command, like we can see where the error is exactly at. And if we, let's say, try to print the value of PTR at this point, we will see that its address is at 0 here, which means that this is an uninitialized pointer error. Yeah. So these are basically what we have just done. So the correct way to do this is just allocating the pointer and then initializing it. Yeah, I guess this part was pretty fast. We have 10 more minutes. We can go over some quick review on C, or if you have any questions, we can take that as well. First, let me ask if anyone wants us to go through some C coverage. This is just basic function writing and compiling for C. Did we see any hands? Oh, okay. Okay. Yeah. Yeah. So here we have a. Are you talking, Abhishek, or? Okay. So we have a. Here we have the simple structure of the C program. As it is very similar to the other languages, if you know others. So on the left, we have the simple C program, and we just have the statement of printing hello world. Here we have the main function, which is the entry point to our executable, and we are just printing the hello world. So the way we compile our C programs is using a C or C++ compiler. Here we are using GCC, and the simplest way is to just typing GCC and giving the C file, and this will, by default, it will create a executable named a.out, and we can use that to execute our program, which prints out hello world. We can also add the -o flag to specify the name of the executable as well. So C or C++ is a type language, which means that for any variable we use, we need to specify its types. And the basic types that we all use is integer, double, float, and char. So we can also use like pointers, arrays, or other data structures. So yeah. So the basic arithmetic operators are listed here. I actually don't know how to go over them. These are, I guess, these are like the basics. If you have any questions about any of these specific operations, I can address them. But I think these all should be pretty straightforward. Any questions? Oh, okay. I see a question about what is the GCC versions on the server. So you can find that out by just typing the module avail command. This will give you all the available options for a specific package with its alternatives. And I'm not sure, but I think there's a version that supports CPP 20. Yeah. So as we said, C or C++ is a declared language. So whenever we are using variables, we need to declare their type. Here we are declaring two variables, A and B, which are type of int, and in the second line we are just declaring them, but in the third line we are both declaring and initializing our variables, and all the names also are case sensitive. So we have this like pretty straightforward control structures that we use in any other language. So if you have any questions here, I can answer them. Otherwise, I will just move forward. So when we are declaring the functions in C or C++, this is the signature, a generic signature, how we define it. So we first have the return type. This is one of the types that we have shown in previously, and then we put the function name and we put the parameter, one or multiple parameters here, and then we have the function of the body of the function. So the definition of scope is the region of the program where the specific variables can be accessed, and beyond that, it cannot be accessed. So here we have let's say that we have a program, and the local variables means that the variables are declared inside that scope or function block are local to that block. So if we have the same variable name inside the local scope and the outer scope, usually the innermost one is the one that will be used for that scope, and the global variables that are defined outside of the function. So the global variables are the ones that are defined outside of the function, which can be accessed anywhere in the program. So then I guess we have arrays, and so here we show the declaration, how we declare the arrays, and we have the type of the array name, and the size of the array. And here the array size needs to be a positive integer. Do you have any questions here? So like in general about these data structures, because that way it will be easier for me to explain other than going through these like basics. I guess one student was asking for the review, so I can maybe talk about the parts that we might have required the review. I'm guessing most of us should be familiar with these data structures. Okay, so one student said parts which are different from Python can be explained. I guess that's a very good point. So as we said, one of the most important part is that first, C or C++, we need to declare the variables. In Python, we just write a variable name, and then we can initialize any type of variable to that variable and any type of value to that variable. But in C or C++, we need to explicitly define what type of variable we are using. And the second one is the Python code. It is interpreted on the fly, meaning that it's not a compiled language. But C or C++, we need to compile our programs, which gets translated into the machine code before the execution. This has several advantages. The most obvious advantage is when we compile our program ahead, then our compiler, the compilers are very smart and they can find good optimizations to do before we execute our program. So as a result, usually our code runs much faster. So if you write the same code in Python and C++, assuming that you are not using any high performance computing libraries in Python, your code will run a lot faster in using C. Should I go ahead? Abhishek, do you have anything to add? You can step in anytime you want.
Yeah, sure. It's like, I mean, you can just go through some, like we have given the reference link and all, like you can just go through basic tutorials and I think you'll be fine if you can code in any one language, or maybe you know the structure and you should be able to do that. You read about the pointers and all, that is important.
Yeah.
Yeah.
So I guess another important thing in C is the pointers. The pointer is a variable whose value is the address of another variable. So the pointer actually points to a direct address of the memory. And like any variable, we must declare a pointer before we can use it. The way we declare the pointers is we just put this star sign ahead, and let's say that we have an integer IP before, and when we add the star sign, it becomes an integer pointer. So in using this, we can convert any type of variable to a pointer variable. So here we have a simple example. We define the variable 20, and then we declare a pointer called integer pointer called IP. And then in IP, we store the address of variable 20. So here, initially, if we print the variable, address of the variable, using this sign, we will see that its address is here. We printed this BFF, starting with BFF. And if we want to actually, if we actually just print the pointer, which we assigned here to the address of the variable, we will see that the value of the IP is the same as the address of the variable. And if you have a pointer and if you use the star sign ahead, this is dereferencing. So this means that instead of printing the address, go to that address, read the value, and print that value. So when we dereference the IP address, we see that the stored value is 20 because we set the IP to the address of the var. So string is another commonly used type of variable. And in C, the strings are generally represented by a array of chars. Here, let's say that we have the word hello. This is represented by array of char. So these are some useful string manipulation.
The syntax is not like what it is, but it's just for the representation. I mean, to make it easy, it's just represented. Like, you can just always have a look at these syntaxes in the documentation.
Yeah, here there are some useful string manipulation functions. the copy command, concatenate command, just returning the length of the string, comparing if two strings are equal. This returns this char, str char returns a pointer to the first occurrence of a char in string 1, and I guess this returns a pointer to the first occurrence of string s2 in s1. So I guess these can be useful in some cases. Yeah, so in many times we also may need more complicated type of variables, or we may need some data structures, and which may need to store multiple values. Here, if you think of a book, each book has a title, author, some theme or subject, and in this case, we define a struct that's called for books, and we define the type of we define what it needs to have. Here, title, author, and subject, and the book ID, and we define their respective types. And when we are now, once we have this book structure, we can just declare a new book by using struct books, book 1. And if we want to modify or access a specific variable within the structure, we can just use its respective names. Yeah, I guess this is the more important part for this class, that like we may face issues or we need to be careful with. So the memory management functions. So calloc, we use this to allocate an array of elements, and here the size is the size in bytes that we will try to allocate. So we use calloc to allocate an array. And when we allocate an array using calloc, if we are not using some smart pointers that are available in the later versions of C++, we need to make sure that we free these memories. Otherwise, we will encounter some memory management issues. So every time we are done with the allocated array, we need to free the array at the end of our usage. So the malloc is very similar to the previous one, but this also, the difference is that this leaves them initialized. And let's say that we have an array, but we need to extend its size. Instead of deallocating and reallocating an array, we can just take the previous address of the array and we can extend its size using realloc. Yeah, thank you. I'm sorry this part has been not good. Yeah, need more practice. Are there any questions? If there are some specific questions, I think for this one it will be easier to respond.
I think if nobody has any questions, then maybe we can just wrap it up.
Yeah. Okay. Yeah.
Okay, guys. Thank you for joining.
Yeah. Thank you.
There's this homework released today, first homework. So just have a look at it and try to set up your clusters, accounts and all. Just to try to begin with it. And let us know if you have any issues. Okay.
Yeah.